Good morning, everybody. Welcome to today's webinar, where we're going to be talking about wireless security. And really what this is the first of a two-part series that we're going to do. Today, we're going to really be talking about kind of a very much a top-down approach to this. We're looking at this from a very high level. And then in a couple of weeks, hopefully you can rejoin us when we get into our net lab, in which we're actually going to walk through the steps, especially with the Esteem products, of implementing best wireless security. And so for the distributors on this call, wireless security is probably one of those big pain points or at least concerns for customers as they're moving forward, putting in a wireless system. When we get into, or for you end users or customers, this is something kind of the same thing. This is really one of the big concerns, or one of the big pain points, or one of the considerations that we have to go through. And security itself really is a multiple layer kind of approach to this. And so we're really just going to address the wireless side of things today. So we'll kind of get through this. There's a lot to go through, so we're going to kind of bump through it. If you've got any questions, go ahead and type them into your box over there on the side of the screen. Perry will be monitoring those, and if not, then we can also get it out to you. But as we kind of start looking into this wireless security, what we want to start kind of take a step back and really kind of look at things is how we got to the point where we're at now. So we start kind of looking at this. What we're really involved with Esteem is kind of in these heavy industries. We're into the water, wastewater. We do a lot of oil and gas. We do a lot of mining. Material handling, power and energy, agriculture, infrastructure, factory floor AGVs. And what we're seeing with this is security is paramount to these types of applications. But what we're also seeing within these applications that's driving that is really kind of this whole digital transformation. We now have kind of moved from just devices talking to each other. Now, all of a sudden, we're taking this into a much more of a networked approach. We've moved from serial-based into an Ethernet-based network, kind of the industry 4.0, if you will. And so when we start looking at that digital transformation model, and what we look at is kind of a connected model today. So we've got things out in the field that we're trying to gather data from. We need connectivity in order to basically get that data, the data itself and where we're going to store that, and then the analytics, because really that's really what drives this whole thing, is how do we actually take the data that's out there and make it actionable information or provide some sort of benefit. So those are really kind of your four pillars of a connected enterprise network: is devices, connectivity, the data itself, and then the analytics or the action. When we take that same model and start looking at those industries that I just mentioned, or kind of the industrial automation side of things, we've got a few, I guess, hurdles or obstacles that are a little bit more unique, or challenges that we have to contend with. And really those things are, we're dealing with much longer distances. So we've got city or county-wide coverages. We're trying to get across waterways. We're trying to get across roadways, mobile applications, remote assets. Basically, things aren't right on the other side of the building. So in these type of situations, wireless itself becomes a very, very credible as well as critical part of the whole infrastructure. In addition to just merely connecting these locations, what we're also seeing now, as rapidly as technology is evolving in the information age, is that we're now bringing in more. We've got the IoT, everything is connected, and we're dealing with this, and that's all done, whether it's cellular or Wi-Fi. But basically, we need that connectivity to everything in life now. So when we look at that, really the biggest pain point or the consideration or concern really comes down to the security of that data, right? So how, is it going to be something that I can trust? If I'm going to put out my critical infrastructure or some of this high level important information, we got to make sure that we've got that locked down. So we kind of look at this data security, or security of data, if you will. It really kind of comes down to this. There's a concern that radio transmitted data is not private or secure. That's really the the nugget here that people have. Now that's even further complicated when we start getting into what they call these open WLAN standards. This is your 802.11, right? And so it's basically what they call an open standard protocol, or Wi-Fi is really part of this. And this is in the 2.4 gigahertz and the 5.8 gigahertz frequency bands, what they call an open protocol. Now we can also consider this security of data with a proprietary. Now, when we look at the open protocols, which is really kind of where the greatest concern is that it does provide a lot of flexibility and a lot of mobility, but that does come at a cost, right? So when we consider open wireless protocols, really what that means is there's not a single wireless vendor. So you can have an Esteem access point talking to a Dell computer or your thin clients or your iPhones or an iPad. It's not locked per vendor. These have very set data rates, and so everybody plays by the same rules. Also, what this brings are very consistent security methods, and so there's very distinct ways that this is done, and everybody kind of plays along by the same rules. It's also very convenient for the mobility side. If you think of this IoT, you can get your data from anywhere, essentially on the planet. If you've got a VPN into that, or we can actually do this, same thing. If you want to take it to your home, it's something you can pull up your Ring doorbell just about anywhere that you are right on your phone. The flip side of this is when we get into a proprietary protocol. And this is basically where it's a single vendor for all your hardware. So when you get into things like a 900 megahertz, a 450 megahertz, 150 megahertz, those types of systems, those are what we call a proprietary protocol. And so in that, basically saying an Esteem 900 megahertz product is only going to talk to another Esteem 900 megahertz product. They're locked to each other, and basically we have flexibility in terms of the data rates, how that's actually secured. Also, what this does is now suddenly we can do a little bit different types of modulation, so we can have different data rates and things of that nature. Probably the biggest, whether this is a benefit or a negative, really kind of depends on which side of the fence you're on. But because it's not an open protocol, is that you're not going to have that luxury of being able necessarily to connect a Wi-Fi device to it. So it increases the security, but it kind of reduces the convenience. So it's really not a which is better, it is which is most appropriate is really the question you look at. So we kind of now take this idea of on the wireless side and we start looking at security. Well, when we kind of look at it, this has really kind of been built over the years. It's really evolved from where it first started off to where we are today. And so when we kind of look at that, these generations of security, is we kind of started off with what they called WEP encryption, which is wired equivalency privacy. Kind of the idea is this is equivalent to security of wired LAN, and it supported up to 128-bit encryption and decryption. Okay, and we'll talk about each one of these a little bit more in depth, but then we went to what they called WPA. Okay, this is the Wi-Fi protected access. It was really an interim solution for bridging between WEP and what was to come, kind of what we have today. And so it really kind of addressed the perceived flaws. So as a major step, it just was an interim step. Then we get into kind of this whole 802.11i. A lot of people will refer to this as WPA2. And this was kind of the complete security update for your wireless LAN networks, okay? And so it was actually released and now implemented. This can be done both, and usually basically was done on a firmware basis. So we kind of looked at these a little bit more in depth or a little closer with what web security is. And why we bring this up is there's still a lot of implementations that are still running on some of these legacy type encryption methods that need to be addressed. When we get into web security itself, it was really designed for very basic network privacy. It was really built to prevent unauthorized listening or monitoring, prevent unauthorized use. We just tried to keep things a little bit more private. It was really never designed to be a strong encryption tool. Without getting too much in depth to that, is basically what the big flaw to this is. It was a static key. So if you monitored this enough, and I guess kind of sniffed that pack or that network long enough, you could actually find out what that key was based on whether it was 64-bit or 128-bit encryption. Within about 20 minutes, you could actually have that key to be able to gain access. So it was kind of had similar problems to what dial-up access had. There was a stopgap that was implemented or put in place with WEP, which was this EAP, or Extended Authentication Protocol, which was a server, which could then basically have to go in and you would have to authenticate yourself, and we still use the WEP encryption. A VPN was also an alternative security method. So with that, the WPA kind of launched as an answer to that. And so what it actually did is it took kind of some of the elements that were going to be coming out in this 802.11i work group, but they wanted to basically expedite this. And so they took some of what they knew, rolled this out within some firmware updates. Probably the biggest difference that came through with this is we moved from a WEP encryption to now all of a sudden it allowed for TKIP encryption, which had a rotating key, okay, as well as some sequencing. So it was a much greater level of security through this because it was much harder to try and to sniff and see what was going on. Also, what it supported was this user authentication, and kind of the common terminology is a radius server. And so this is something that you could use. And so WPA supported both what they call enterprise mode, which was your radius server, and it used this, what they call 802.1x for your session keys. So we can now have a server added to this rotating and key, which offered a much higher level of security. Again, this was not made to be the end all. It was made to be that interim solution to take us from a poor method of encryption up to a much superior level of encryption. So once we got into this 802.11i, or what a lot of people will call WPA2, is that it was really kind of a complete security package update for the wireless LAN networks. Okay, the whole idea. It still supported TKIP for those legacy products, but at the same time, now all of a sudden we introduce Advanced Encryption Standard, which most people just know as AES. This goes into both AES 128 and 256 are the most common. There is also some what they call AES 192. This was kind of the official government standard. So the most common implementation of this is your 128-bit is what a lot of things are going to come with, and some of that gets into importing, exporting, but that's really what you're going to find kind of your common thread within all your wireless networking now. Okay. What it also supported is that we can have not only the authentication servers like we talked about, but it also has pre-shared keys. This is kind of that password that you have in order to get in there. They call it a passphrase. So what this really allows is, especially for our industrial applications, a lot of times they're not connected to a radius server, so the pre-shared key is very valuable. So we're not limited in that, but it also still does support that enterprise method for the highest level of security and authentication server. So what usually kind of comes up is, okay, so we've got AES 128, which is kind of the most common. How secure is that? Okay, so when you kind of take a look at this and start looking at what is it actually, how secure is it, how long will it take to try and break into this, you can kind of take the numbers. Is if you look at 8 bits, is actually there comes 256 combinations that we can have there within our 8 bits, right? So now all of a sudden we move this out to 128 bits. Now all of a sudden we're jumping by orders of magnitude of how many combinations we have. And so you can see here that we've taken this exponentially and saying, you know, this is going to be incredibly complex, not to mention only this. So first say, okay, taking that for granted, what would it actually take to try and crack this? So if we look at this, time to crack 128-bit encryption AES is assuming every person on the planet owned 10 computers. Give or take, we've got about 7 billion people on the planet, and each of those computers itself, they can test 1 billion key combinations per second. Kind of least when you get into the cybersecurity world, is on average you can crack the key after you test about 50% of the possibilities. So how long would it take to actually do that, provided that everybody on the planet had 10 computers and that we could power those? The number that you see here is 77 septillion years, okay? So if you've not heard the word septillion, kind of where it ranks on the scale here is basically, you can see where we've got our friends in Washington that are now talking in the $1 trillion or trillion range. You can see down, we're down now at level 7, and this really goes to how many zeros are there. So when we start looking at 77 septillion years, in order to crack this, it really kind of brings things into perspective, especially when you start considering that to date, and I don't want to get into a debate or anything on age, but kind of the generally accepted is we're about 4.5 billion years is how long the Earth has been in existence. So look up on that scale above, we're looking at billions versus the septillions. It's an incredibly secure side of things there in order just to crack that. So kind of keep that in mind when you start rolling these things out. So we start looking at security. We really want to take a step back and take a security assessment. We want to look at this. Okay, what do we need to consider? Okay, the first thing is the vulnerability of that data. What's going to happen if that data is lost? What would happen if it's intercepted? You know, what would happen if bad data were injected? Really, these are just questions you need to ask. Is when you start looking at security of this, is what would happen, right? How vulnerable is that data? So then what we also have is how vulnerable is your wireless network? Again, wireless is just a certain aspect of this. Is how vulnerable is the wireless network? Is it an open protocol, or is it going to be a proprietary protocol network? Can the wireless network be used as a bridge to other systems? How far, if someone were to gain access, can they basically implement into your network? And then finally, it's, you know, what is that company security policy? And there's various different methods, different reports out there, but it should be a policy for the company of where this is being implemented. Is how do you actually do that, your cybersecurity? I'm going to touch a lot on this. Like I say, we could spend days or weeks going over just on security itself. So we're trying to keep this with your time in mind down to about a half an hour. So we're going to kind of keep moving. So really, when we start looking at those threats to security, really there's two sides of that. We've got intentional threats and we've got unintentional threats. And basically what we're going to kind of look at those as, okay, so when we're designing this, we're implementing security with those two in mind. Okay, so when we get into intentional threats to security, what that is basically attempts to get into that network, whether that's just to cause problems. You've got a disgruntled employee, you've got somebody that's just kind of being a pain in the butt. You also have somebody just trying to gain free internet access. You know, this is usually more at the home or at a hotel. They're just trying to use that Wi-Fi, so they're trying to get into that network for that reason. Max spoofing, so they can try and be somebody that's already on your network. You're going a step further. Now all of a sudden you have to say, okay, if it's not just trying to get onto the network, are they trying to shut down that network, intentionally shutting it down? We call this denial of service attacks. So we may not necessarily be trying to gain access to it. We're just trying to prevent your information from going across this. Yeah, this is another type of a threat to your security. Then you have kind of the stealing or injecting invalid data. This is very, very difficult to do, if not impossible to do, kind of at an individual level. Usually this is kind of at a state level or country to country. A lot of the stuff that you start hearing about within the news when you start implementing these, this is a very high level of a breach. Okay. Then we also have unintentional threats to security. And these are also things we need to consider. This can be something just as simple as bad wireless hardware. You could have something that is off frequency, out of band specifications. They're emitting more power and they can actually shut down your network because basically you've got a higher amount of interference or noise out there than you do your own signal. Okay. again, that high RF noise and this can be electrical hardware. It could be something as simple as, when they're working out at a location and you've got welding equipment going on, that can cause electromagnetic energy that can disrupt that network. Again, it's a threat to the security because that data isn't going through. Then we can also have it just by simply overloading that network. Okay, these are generally not intentional, but ultimately you've got more people trying to pull more data than what that pipeline can actually support. And so exclusive wireless channels are not generally required, but they can be. We can isolate those networks and say, okay, we're going to try and segment this so we have additional users jumping onto different channels, right? So as we kind of get into some of the best practices, is we want to look at this and say, okay, what do we do? How do we actually roll this out? Okay, well, one of the biggest things that you can do is that we want to get into where we're using static addressing. We want to disable DHCP for mobile clients in those remote locations. Why we do this is if someone were actually to be able to get onto that SSID, somehow gets a hold of the key, we don't want to hand them a valid IP address on your network. We want to basically continue to add hurdles or barriers along the way. And so just using static IP addressing is a very, very good security practice in the wireless networks. Also, we want to make sure that you're updating and rotating those security keys. Now, this is probably the biggest thing that we can do, especially when we look at the wireless side of things, is make sure we're using the latest security methods or encryption methods out there. If you've still got, networks that are running on WEP encryption, we need to get that firmware update or get that equipment replaced that supports adequate encryption. Basically, we want to get everything up that can do AES 128 or 256 at level encryption. You can also go in and actually now take this to a enterprise mode where we employ a Radius server that not only do you have to authenticate as a user before that key is passed. Also, you want to set a policy on how often are you changing that key or are you rotating that key. Okay, this is kind of like the same thing you get with your passwords on websites, is you don't want to continue to use the same key over and over and over, as a lot of bodies and a lot of employees are getting rotated through. So we want to make sure that those keys are different. Also, from a network administrator side, you also want to do a periodic network survey. We need to know if we have rogue access points on that network. Okay, kind of moving forward a little bit more is the other one is probably the biggest one is use the available security you have. We have a lot of the older networks that simply didn't have encryption turned on. Make sure that you've got it actually enabled and turned on. The latest encryption. If you're not using Wi-Fi access, we can actually disable that so that we're only using that as the straight bridge between devices. If you want to use 2.4 gigahertz and we want to, at the factory, we want to have that open for Wi-Fi access, but maybe those remote sites, we can just turn the Wi-Fi access off. Okay, we can disable the SSID broadcast and the discard probes. What that does is basically when you pull up and you're looking for those networks, you're not going to see the name of that network, which is kind of your first level in order to make an association or connect to that network. Now, if your device is already programmed with this in, that's great. Now, all of a sudden, you'll still connect to those networks, but to somebody out there trying to just scan for open networks or scan for wireless networks, they're at least not going to see that SSID name out there. And you can also enable what they call protected management frames. This is something new. This is something that is hardware driven. So check with your devices on a lot of not only on the access point side but also on the client side, whether they support this. Be very careful with this, but it is something that also protects those management frames and encrypts those so that even those can't be sniffed out. Okay. So when we start looking, another method to try and do this is what we're calling segmentation. And so when we start segmenting wireless networks, there's various ways that we can do this. Is we can actually segment, the entire wireless network into subnetworks. And you can do this by frequency. We can change SSIDs out there. We can even have multiple types of APs out there. We can go into what in the Esteem terminology into a masquerade mode, which is essentially is a firewall. So if they do get onto the network, we want to prevent them from getting onto the whole network on things. We can actually configure that within the network itself or on individual links. Now, if you're with us a couple weeks ago, we were talking about twin bridge technology, which is something that Esteem has implemented into the Horizon series that allows us to segment networks on one set of hardware. And we'll do a quick review of that just here in a second on there. When we start looking at segmenting these networks, if you kind of take a very basic network architecture, and when we start talking about segmenting, really what we're doing is we're breaking them up into individual little sub networks so that we can actually isolate these or air gap these from each other. If it doesn't necessarily need to all be on one network, it's a very good security practice to basically segment those or air gap those. As I mentioned just a minute ago, we've also got what we call twin bridge technology. And really what this allows us to do is to create two separate bridge mechanisms that run simultaneously, but completely independent and completely isolated from each other across a single wireless infrastructure. Okay, so we can actually literally air gap those two networks on a common radio. And so this is going to save you cost of adding hardware. We can reduce the complexity by having multiple devices out there, and it really just basically adds to the security or increases your security for that reason. So when we look at that, and again, this is kind of in review, is you can see that we can have a processor, a SCADA, a control network, which you would see here within the red lines. And then we could actually go in and create a second network that would go into a second Ethernet port, say for your IoT or your visualization. They can run out to, and they can go to some of the common locations. They can be completely independent from each other. You can define exactly where these go, but it runs on one single wireless network. Very powerful. Okay, another tool that you have at your disposal for security is what they call an access control list or an ACL. Really what this is it's an additional security overlay that can be added to your networks. And really what it is, it's a MAC filter, right? Is you can program this so that you can say allow all MAC addresses that have the correct SSID and encryption. We can go in and allow only particular ones. So you can say, okay, these MACs are allowed onto my network. And those are the only ones I'm going to accept, or we can actually deny those. And so the MAC address is basically set at the factory. And so it is something that's unique to each device. So again, it's not the end all be all, but it is probably one of the strongest levels of security that we can add to this. It's very simple, it's very secure, but it does take, say, a physical compromise would be required to get on there. So, but this method does take more management because you've got to add those MAC addresses in there. Again, you can also deny some. So if you've had some devices that were basically stolen or disappeared, or if you had an employee that, and if you have a bring your own device policy and that individual is no longer with the company, you can actually deny that so that they can't come back in and access the network. Okay, another thing that we can look at is proprietary bridge networks. Now, what does that mean? It all sounds great. Okay, so even within the 2.4 gigahertz is this 802.11. What the 802.11, whether that's B, G, N, A, AC, there's a lot of different alphabet soup to that, and all those go with something. But really what that defines is the access point to a client. So think of that as the access point out to, say, your laptop or your phone or your tablet. And so what it doesn't define is those AP to AP connections, or what we call those bridge links. So those are operating on a proprietary Ethernet link strictly between MAC addresses. We can also, and we individually secure those with using the same type of encryption, using what they call CCMP, which is based upon AES. Okay, still supports the repeating and all the other modes of operation, But this is separate. Even though it's running at 2.4 gigahertz, it doesn't fall within the 802.11 world. So we can now all of a sudden, we can isolate this actually who can talk to each other. Okay, so this really does extend your security. But if we want it just to be a proprietary bridge, then of course it wouldn't be necessarily an access point itself. Okay, this also eliminates kind of the open standards. So open standard equipment aren't going to connect to this network. So again, it's not a this is great, this is bad. It is which is going to fit with your overall security needs to give us the most secure network that we can possibly get. Okay. So then what we've also got here is, so we've kind of touched on what it takes to secure these networks, but what we're seeing in today's day and age is that we have a need to be able to now access these networks, not only just from kind of in the closer range, say within these miles, but now all of a sudden we're getting like, I want to be able to remotely access this from a different location, whether that be in a different city, different state, maybe even a different country. Okay, it may just be something we want to bring in a remote station that we can't get to from a standard wireless network. Okay, and so what this is typically this is done with like an LTE or cellular connection. Kind of a different ball game than what we were just talking about. So we're going to touch on it real quickly. Is when we start doing that, is Steam has what they call it the Edge Access Plus. Now, what's a little bit different with this is that this does offer complete edge-to-edge connectivity. It's very simple, it's very secure. And so this can be used for remote access, bridge networks, point-to-point. It's very much an unlimited network scalability to it. Now, what's key to this is basically connections themselves are automated. They're self-creating VPN encrypted connections. We eliminate the human error and the complexity of that completely. This does allow us to have both or all three of our LTE, Wi-Fi, and copper connectivity. We can run these things in both layer 2 and layer 3 type of connections. So that's your bridged or your routed connections for remote maintenance, remote connections. Okay, that data can be either brought in from the edge itself, right, directly to your network, or we can push it out to the cloud. And it's not that we're anti-cloud, it's just what we see is that this is your data, so you decide whether you want to do with it. If I want to just have a dedicated VPN connection out to a remote site, or if I want to monitor this, there's no reason to involve the cloud. Now you can also use this up in AWS or Azure Cloud. Okay, so all of this is a point-to-point data flow. So no matter how many we put out there, each one of these VPN connections are AES 256-bit encrypted. Okay, so this is probably the simplest thing that you'll ever set up and one of the most secure connections. So when you take these devices, this Edge Access Plus, really all you have to do in order to generate this is we plug in this crypto key into the top of that, and that mates those two devices together. Basically, now we form a bond. So now all of a sudden, that we've got a connection between that key and the Edge Access Plus, a very secure connection. And that connection can be really anywhere on the planet. Now, really don't necessarily care, or you as the end users don't care about having a connection between the Edge Access Plus back to this key. What you're looking for is a connection between what the data you're trying to get and the data itself, right? So you can now actually connect your right straight from your computer to anything that's sitting on the other side of that. Excuse me. And we also support larger networks. So maybe we have, 5 of these devices out there. Well, now all of a sudden what we're going to do is rather than just running from a single key that's made into each of those, is we create what they call essentially a central lock. And so it's a piece of software that runs in a virtual mode. So you can run this in VMware, you can run it in VirtualBox, you can run this in Windows Hyper-V. And so now all of a sudden we have full access and connectivity to all those remote devices, bringing it right back into our network. That can just sit right on either a computer. You can actually put this right onto a server. Now, the other side is because it has Wi-Fi access, we can also bring in thin clients or provide Wi-Fi access into that same thing to take advantage of that same link. Now, if you want to implement this into the cloud, that isn't a problem. We can actually just take that and install that same virtual central lock up into the cloud. And you can put this, if you've got your own AWS or Azure accounts, if not, that actually can be managed itself, directly through our partners. Again, it's housed in the cloud, but it doesn't require cloud connectivity. And that's really a big key to it. So I know we're running a little bit over on this, and I want to be conscious of your time for joining us. So when you kind of look at this, just some simple conclusions, is realize that wireless security itself is really kind of a first level effort in multi-level security models. So don't rely on it to be your complete security, but it is going to be a critical step or a vital part of your overall security. Right now is the time to implement and get that security policy. What do we want to do with this? The piecemeal or patching things, always, those days are gone. We've got to have this thing, implemented, and it's got to be kind of company wide in terms of your security side. We want to basically also use the highest level of wireless security available. If you've got those older systems that are still running on WEP or on TKIP, it's time to get them updated. Today's day and age is we've got to get these up to AES encryption, whether that means it's a firmware update or it's an equipment replacement. We're just at that point where we've got to get these things bumped up. And then understand that there is wireless network that's available beyond just simple Wi-Fi. Like we talked about proprietary bridging. We can do this at 900 megahertz, 2.4 gigahertz, 5.8 gigahertz. We can even get down into those lower frequencies or cellular. Kind of think of there's a lot of different possibilities that we can use for this wireless networking out there. And again, this is an ongoing process, so it does require diligence. It requires you to be flexible. It requires you to be able to adapt. That's kind of what we're going to cover today. Like I mentioned, this is going to be a two-part series. So what we're going to talk about in a couple of weeks in the next Net Lab is really we're going to step through actually securing that network. How do we actually implement these things that we talked about today? And it's going to become a little bit more of a nuts and bolts as we're going to walk through and talk about this, say, on the Horizon series, and what does this actually mean? What does it look like? What does it touch, taste, smell like? So I hope you can join us in a couple of weeks. I thank you again for joining us. If you've got any questions, feel free to either jot them down. You can shoot us an email. You can give us a call. But that is going to be, you can say, I apologize, we ran over a little bit, but there's a lot of data to try and cover, and I've just step one of two. So if not, have a great day, folks. And I hope you can start putting this into play and can join us again in a couple weeks. Thanks.